Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 23 of our 30 LeetCode challenge, and the problem which has been given to us today is the bitwise AND of numbers range. So if you want to try solving this problem, do go ahead and pause this video and find the LeetCode link in the description below. But let's just dive right into the problem description. So you've been given a range m, n where 0 is less than equal to m and m is less than equal to n, and n is less than equal to some big value, and you need to return the bitwise AND of all the numbers in the range inclusive. Inclusive meaning that m and n are inclusive to the range. So you've been given an example over here where you have 5 comma 7 and the output has been given as 4. So if you know how bitwise operations work, that's, well, you can sort of skip forward, but I'm just going to write this thing down. So when you say that you have a range of 5 comma 7, what you're saying is you have elements 5, 6, and 7. And the bitwise operations for 5 is 101, for 6 it's 110, and for 7 it's 111. And I'm just going to give an index to all these guys, even though when you look at indexes, you look from right to left. Just for the sake of clarity, I'm just going to give it 0, 1, 2. And when you do an AND operation over here, what you'll see is you'll get an output of 4, and 4 is represented as 100. So essentially, if you don't really understand bitwise operations, a quick note on that is if you have an AND operation, basically looking for similar values. If you have a similar value, you give it a 1, otherwise you give it a 0. So if you do a bitwise operation of 101 separate, so you do 1 and 0 and 1, that's 0. Similarly 0, 1, 1, that's also 0, and 1, 1, 1, which is, well, that's a 1, so that gets a 1. And in a bitwise operation manner, you can sort of calculate this thing out, and that's a 4. So there are multiple ways of doing this. You could literally just go through all the elements inside of 5 comma 7, maintain this thing and move forward with it. The reason why I don't really like bitwise operations in Python at least is because Python, I mean, like all programming languages are not really that good while you write, bitwise operations. But keeping that aside, I hope you sort of understand the logic over here of how the thing works. While we sort of move forward with our implementation, there are a few quick hacks if you want to just loop over all the elements that you're moving forward. In Python, you can actually just write bin, or you can use a string formatter that is, which can sort of return all these guys. So when you do, let me just return a 0 here so that it doesn't throw an error. So when you do bin and you pass it a number, it's going to return the um, the bit representation, sorry, the bit representation of that integer. So you can see over here you have 5 comma 7, and output is, you can like sort of ignore the 0b, that's just a way of representing whether it's a bit representation. um, and you can see it's 101 for 5 and 111 for 7. So if you want to move forward with the logic which I just told you about, where you iterate over all the elements, you can probably use that. But there is a more optimal way of sort of going about it, and you can sort of already look at look at it from evaluating the um, bit representations that we've sort of written down. So if you have a look at all of this, you can see that our breakaway condition in essence is when there are, well, values which are similar to each other. If you sort of move forward with a huge value, you would basically try to look at values where you have 5 and 7 as same. So when 5 and 7 are same, you can, well, at least a bit, right? So if the last bit of 5 and 7 are the same, you can look at, you don't really need to look at all the elements inside the value, inside that range. So you can just remove this, and you just have to look at 5 and 7, and your breakaway condition becomes that whenever these guys are equal to each other. But that would sort of help you just for handling a few cases. If you sort of look at this guy, if you start from, well, you know that if you start from right to left, so let me just make an arrow over here so you go um, right to left in bit operations. So when you look at that, you can see that 1 and 1 are the first things which are actually equivalent to each other. So do we break out over there? Well, no, we don't really do that. But what we can do is we can try to, remove that value. And when we remove that value, we're going to have another representation. So let's just remove this. and we're going to say while 5 is equal to 7, or rather our breakaway condition becomes we're finding a value where m is equal to n. So that's our breakaway condition. And intuitively, if you keep on splitting it out right now, you can see that this becomes 2 and this becomes 3. So 2 and 3 are also not equal to each other, so let's just remove the next values. So we remove that value as well. So we have 1 and 1, and that represents as 1 and 1, and that is equal to each other. So that's basically our breakaway condition. So all values after this are basically going to be the same. That's just like a property inside um, that's just like a property inside bit values, right? If you think about a larger value, um, let's take a tricky value. Let's take 13 and 12. So 13 and 12 should be 1 0 1 1 and 1 1 0 0. Oh wait, that should be 1 here and this thing here. So 1 plus 4 plus 8, so that's 13, and 8 plus 4, that's 12. So as soon as we find this guy, which is basically going to say that hey, everything after this is the same, we can ideally just say that this is our condition. This is the breakaway point for us. Everything else doesn't really matter because they, by definition, cannot be equal to each other because a bitwise operation is just going to keep on adding ones on it. Anyways, so that's my explanation of it. I hope that sort of makes sense. If it doesn't, you can sort of look at the code. It'll make it a lot more easier for you to understand. All right, cool. So let's just dive right into the problem. So the way we usually just start off is just by talking about whether there are any nonce inside, just handler-based conditions. So if m is not given or n is not given, you return a 0. So that's pretty straightforward. Now what we're going to do is we're going to maintain a value which is just going to be equal to shift, and we're going to iterate over m and n, but the iteration would happen till m is not equal to n. I hope that sort of makes sense. Inside bitwise operations, this is where things become a little tricky because if you don't know bitwise operations, it becomes a lot more difficult. So what we're going to do is we're going to do I don't know the proper terminology, but I like to call it a left shift. So that means that you're just trying to go on the left side. So you're trying to do a shift on m and you're trying to do a shift on n. So basically what you're trying to do is you're trying to find the next value. So let me just do a quick print over here, and I'm just going to print out m and I'm just going to print out n. And let me just also print out m and n so you have a better intuition of what's really happening. So when you do this operation on the left hand side, you just remove that and hop over to the next value. So if you look at this thing, if you remember 5 and 7 were 101 and 111. So the bit representation of 101, you're literally just skipping over. You're doing a left shift. You're just moving on to the next value, which is 10, and that's what you have. So you have 10 over here, and you have 111 over here. You could actually just if you don't really want to show off your um, binaries or bit representation skills, you could also just convert m and n into a string and then pop out the last value. I mean that also works. That's actually more easier to understand. So you can do that, and essentially what you want to do is you just want to do a shift, and you want to update the shift to plus equal to 1. Now the reason why you're updating the shift is because it sort of helps you understand like where do you want to actually go. So everything shift is sort of taking into account right now are nothing but a bunch of zeros. That's all it is. So shift just maintains the total number of mismatches that you've had so far. And when you have a mismatch on how many zeros you actually want, what you can do is you can use the same thing of a right shift, but inside a right shift you can literally just pass in the shift value, and that will just add in the values that you want. Um, I know it's sort of a little difficult to understand what I'm saying because most people are not really familiar with all this, but that's okay. You just have to bear with me. Basically, you want to just return m um, m of right shift of this thing. So what this is going to do is you're going to have m as 1. That's your breakaway condition. But shift is going to be the number of zeros that you've encountered so far. So in our case, that's equal to 2. So basically, you're adding 2 zeros in front of m and you're just moving forward with that. So let's just go ahead and run this problem. Hopefully this should run fine, and you can see it's running fine. Let's go ahead and submit this, and hopefully this should get submitted as well. And you can see it's been accepted. And like going back to what I was just talking about, like there are better ways of solving this problem. You can literally, if you want, this is based on all preference. If you want, you can change this thing into a bit string. This is something that you sort of use. Let me just give m over here, and sort of move forward with that. Or you could just use the bin operations that I sort of talked about. You can just do m equal to bin, or whatever you want, and just pop out the values as you're sort of moving forward. That also really helps you out, because then you're maintaining strings, and strings is still a lot more easier to understand, for most people at least. And in an interview too, what the interviewer would like for you to do is use bitwise operations, and that's just how it is sometimes. Yeah. Um, so that was it for today's video. If you have anything, if you didn't understand something, do leave it in the comment section below. And if you did like this video, do give a like and do subscribe to our channel. We have discussion over here, and we would love to have you on board with us. If you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.